We are moving into a new section of the syllabus now, and it's the section of analytical geometry. So up until now, you have seen geometry, but we've been dealing just with Euclidean geometry. So that was founded by one of the greatest mathematicians, a guy named Euclid, and that's the statement and reason kind of geometry. That's Euclidean geometry. But now we move on to geometry that occurs on the Cartesian plane, and that is known as analytical geometry. And I think it's a section of the syllabus that you are really going to enjoy because it's a very practical and very logical section of our syllabus. Now, at grade 10 level, there are 3 formulae that we need to know that pertain to analytical geometry, and so we're going to dive straight into those in this video. The first formula is known as the distance formula. So if you wanted to know the length of a line segment, there is this formula here that we can use, and we literally need to have 2 points on our Cartesian plane, and we need to decide one is 0.1 and one is 0.2, and then we can substitute into this formula. Okay, just for interest's sake, this formula is actually derived from the theorem of Pythagoras. So basically, if you were to draw in some sides here to create a right-angled triangle, you could essentially then make this your hypotenuse, and then you could work out the length there. And so this is an adaptation of Pythagoras' theorem, which most certainly makes our lives a little bit easier. So we can straight away just say, okay, if I'm asked for the distance of this line segment, I don't need to worry about drawing any triangles or anything like that. I can simply say AB is equal to, and when I write it like that, I'm referring to the length of AB. Okay, then what I need to do is I need to decide, okay, let's call this point here x2 and y2, and let's call this here x1 and y1. Okay, so the formula says x2, which is 5, minus x1, so minus 3. Remember, a minus and a minus makes a plus. Okay, and that's going to be squared, plus y2, 1, minus y1, so minus 3. There we go. And that's squared, and then all in a square root. Okay, now very important, you need to read your question, because the question is going to either say that we answer in surd form, or they might specify the number of decimal places. So we just need to be sure that we are answering correctly. Okay, when they say surd form, they mean leave it in the simplest root that it can be. Okay, which most of our modern day calculators are going to do for us anyway, so that's really helpful. But if it tells us the number of decimal places, then we would obviously change that on our calculator to see what we get. Okay, so let's calculate this. 5 plus 3 is 8, and 8 times 8 is 64, plus 1 plus 3 is 4, and 4 times 4 is 16. Okay, so that's the square root of 64 plus 16. And so that's the square root of 80. Okay, now if the question had said surd form, I could stop there. If the question doesn't specify grade 10s, then what you need to do is you need to go look at the cover page. And the cover page will probably say to you, give your answer to 2 decimal places. So if the question doesn't state, then we are going to assume that the cover rule is what applies. And so we're going to work this out on our calculator. And the square root of 80 is 8,94 units there. That's a length, a distance. Okay, so there, by using the distance formula, we have worked out how long this line is. Let's have a look at some of the other formulae that we need to know. Next up is the midpoint formula, and the name very much gives this one away. The point in the middle of the line segment. So we can imagine that somewhere here is a point M, and we don't know what its coordinates are, but we have a formula that we can use to work it out. Okay, so once again, we need to have 2 points, and so I'm going to do it the other way around this time. X1, oh, actually, I think this was the one from last time too. Y1 and X2, Y2 over there. Okay, now we simply can use this formula. So M for midpoints is equal to x1. X1's coordinate there was minus 3, plus x2, so that's plus 5, divided by 2. And then y1 minus 3 plus y2 divided by 2. Okay, M, pointy M here, just so you know, we use a capital letter for midpoint. All right, the curly letter refers to gradient. So it's important to get our notation right. Okay, minus 3 plus 5, that makes 2. And 2 over 2 is 1. And then here, minus 3 plus 1, that makes minus 2. And minus 2 over 2 is minus 1. Okay, and if we look at the sketch, that seems very accurate. That point could easily be the point 1 and minus 1. We can see this is definitely not drawn to scale, but it is at least in the right quadrant to match up to that midpoint that we've calculated. Okay, this last one is so fantastic because it's actually not a new formula. This gradient formula is the gradient of a straight line. And we were introduced to straight line graphs in grade 9. We've studied them when we did the functions section, which is a paper 1 section. And now here gradient visits us again. In fact, the whole equation of the straight line is going to visit us again. So here we are, and we are able to work out the gradient of this line segment by using this formula. Okay, so once again, I'm going to say x2, y2, and x1, y1 over there. Okay, so gradient is equal to y2, 1 minus y1 minus minus 3. Remember, minus and a minus makes a plus. Be careful of your signs there. x2, 5 minus a minus 3. So 5 plus 3. And we end up with 4 over 8, which simplifies to a half. So the gradient of this line is equal to a half. Now, before we get too far down that line, let's quickly just refresh what we know about straight lines, and specifically the gradient of a straight line. If you have two straight lines and they are parallel to each other, then the gradients are equal. And remember, small letter or curly m means gradient. So the two gradients are equal, and that makes sense. If you were to picture some parallel lines, there they are, they'll never ever touch, and so automatically that means they must move at exactly the same gradient. Okay, whereas perpendicular lines, those are slightly different. Okay, those are lines that definitely do intersect, and they intersect specifically at 90 degrees. And so if that's the case, then we can also use the gradients, and we can say, okay, well then gradient 1 multiplied by gradient 2 must equal minus 1. Okay, so let's say that we've got this line here, and the gradient is 2 over 3. Okay, I'm going to do that. Gradient over this line here is 2 over 3. Okay, then we can assume the gradient of the other line is also going to be 2 over 3. So for parallel lines, nothing to work out. But for perpendicular lines, if I know that M1 has a gradient of 2 over 3, then I can work out M2. So I can say, all right, well, my formula says M1 times M2, so 2 over 3 times M2 is equal to minus 1. And then what I want to do is divide both sides by 2 over 3 so that I can solve for that M2 over there. Okay, so now I've got M2 is equal to, and this line here means divide. So if I wanted to change that and work it out, I can tip in time. So I could say minus 1 multiplied by, and then we switch it around, 3 over 2. And so that is minus 3 over 2. Okay, and if ever you're looking for a little shortcut or a trick, then what you can do is you can say, well, for parallel lines, for perpendicular lines, the gradients are actually just the negative reciprocal of each other. So if this one here is positive, this one will be negative. And can you remember what a reciprocal of a fraction is? That's when we switch the numerator and the denominator around. Okay, so that's a really helpful shortcut to remember. Parallel lines, identical gradients. Perpendicular lines, they multiply to equal minus 1. Or, shortcut, change the sign and give the reciprocal of the fraction. So now that we've refreshed our memory on straight lines, let's have a look at working out the equation of this straight line. And that's another formula we know well. Y is equal to mx plus c. So we've worked out the m, and then we need to work out the c, which is the y-intercept. And if they don't give it to us, we can substitute a point into the equation. Okay, so let's first of all substitute the gradient. So y equals a half x plus c. And now let's take one of these points. I'm going to take the one that doesn't have any negatives. So I'm going to substitute 5 and 1. Okay, so in the place of y, 1 is equal to a half times 5 plus c. Half of 5 is 2.5 plus c is equal to 1. And then let's move this 2.5 across. So that's going to go to that side. It's going to become negative over there. So 1 minus 2.5 is minus 1.5. Okay, and you're welcome to do this on your calculator. I'm just having a look. The fractions don't seem too complicated for this one. Okay, so therefore y is equal to gradient a half x and the y-intercept minus 1.5. All right, so let's have a look at everything we know so far. We've got a distance formula, which helps us to work out the length, a midpoint formula, which helps us to work out the center of a line segment, the gradient formula, and then the straight line equation. Okay, and there's this other one that you may see on a formula sheet, and it is another variation of the straight line graph. So instead of having y equals mx plus c, you will say y minus, that's a normal y. y1 is the y-coordinate of a point, m is your gradient, x is a normal x, and x1 is the x-coordinate of one of the points on the line segment. Let's see if we can really put our knowledge to the test with this challenging example. So in the diagram below, triangle PQR is a right angle triangle. PR is produced to point S. That essentially means these are all on a straight line. And now they say if R is the midpoint of PS, then determine the coordinates of S. Okay, so let's have a look at this, because our midpoint formula is normally to work out the midpoint. So in this case, the reason why I say it's a bit of a tricky one is because actually we are given the midpoint, and now we need to work out some coordinates. Okay, so first up, we are going to just write down our formula. Okay, our formula says in order to get the midpoint, we say x1 plus x2. So I'm going to say x plus 1 over 2, and y plus a minus 2, so y minus 2 over 2. Okay, and what we know is that that midpoint is actually not even called M, it's called R. That's what the question says. Okay, and we know the coordinates of R. R is 2 and 3. So actually R is 2 and 3. So essentially what I can do is I can just break this up into two equations. I can say, well, x plus 1 over 2 must equal to 2, and y minus 2 over 2 must equal to 3. And then I can solve. Okay, so let's start out by timesing by 2. What I do to the one side, I do to the other side. Okay, so that's going to end up being x plus 1 equals 4, and x is equal to 3. And then on the other side here, we're going to times by 2 again. So times by 2, what I do to the one side, I do to the other side. So we get y minus 2 equals 6. That's going to become plus 2 when we move it over. So y is equal to 8. And so therefore, S has the coordinates x of 3 and y of 8. Okay, so important to read your questions carefully, because if we had worked out the midpoint here with the 2 that we were given, we'd end up with a random other point here, and that's not what the question was asking for. Okay, and then next up, they want the gradient of QP. So that's normally y2 minus y1 over x2 minus x1, but we don't have any coordinates here. So again, we're going to need to think and say, okay, well, what about this 90 degree? Because I know that the two gradients, if I multiply them, they need to equal -1. So let's work out what we do know, and we can most certainly work out there then the gradient, curly m, of PR, okay, y2, 3 minus y1 minus 2 over 2 minus 1. Remember here, when it was minus minus 2, a minus and a minus makes a plus. Okay, 3 plus 2 is 5 over 2 minus 1 is 1. So we end up with 5 over 1, which is essentially just 5. But because I need to do the reciprocal, I'm actually going to leave it. And I'm going to say, okay, well, that's that one. And now let's work out the gradient of this one. So the two gradients, I can multiply them to give me -1. Or we can use that little shortcut that I told you about, where we say, well, therefore, the gradient of PQ is equal to, we change the sign, so it was a positive gradient, it's now going to be a negative gradient, and we use the reciprocal of the fraction, 1/5. And there you have it. So some nice application questions on your foundations of analytical geometry.